All right. Let's get going. All right. Let's get going.
I think the audio is coming through from the
It
stream.
is, yeah. I'm watching myself type on it. All right, so we've got a really fun set of presentations from Alex here. So, yeah, let's get rolling. Alex, you want to share your share your deck, and then we can get into some quick intros and get this thing going. All right, so today we're going to be jumping into how to architect AI agents with this understanding of security, right? From an attacker's perspective. What we do all day, every day is break AI agents and AI systems, AI applications. We're pen testers at heart, and when building applications, we also are engineers. So as we're building these applications, we are looking at it from a resiliency standpoint, and what are the things that we can and should be doing from an architecture standpoint to ensure that these AI agents are architected in a hardened manner, and it's a lot easier said than done. So Alex was able to give this great talk a couple months ago in Toronto on how to break agents, and it was an incredibly wonderful experience for I think everybody in the room who were just getting into this concept of agents. And um, the thing I came out with was most folks didn't quite understand how easy it was to break these agentic workflows. So what we're doing next is saying, okay, we've shown you how we can break these things. How do we fix them? How do we build them from the ground up to not be that vulnerable? So wanted to reintroduce Alex to you. So Alex is the staff security architect at ZeoSec. He's led design and implementation for our attack platform, but importantly, he's a red teamer and he is a software architect. He's led research. He's built lots of defensive products as well as offensive. And he's got just a tremendous amount of experience, and we're really grateful to have Alex with us today to lead us through this talk. So, without further ado, Alex, take it away.
Thanks a lot, Aaron. I appreciate the intro. All right, so what we're going to start with here and how we frame the formatting is I am going to just quickly run through the previous attack examples we presented. I'll cover the setup. I'll cover the methodologies we used. And for the audience, we tried to keep these very straightforward. So these are direct prompt injection examples. Once we get through each of these examples, we will then really just open it up to full Q&A. And we're hoping to make this very conversational. Aaron's going to ask me some questions. I'll provide some answers, and we'll kind of walk through the thought process behind how to architect security solution protections for these attack examples. And as I'm sure you guys are aware, the industry is rapidly changing and evolving over time. We're seeing tons of new ideas come out of development. We're seeing tons of new products come up, and it's honestly it's a little overwhelming to try to keep track of every little new thing and vet that and validate and determine what is a best practice here, what is the best tool we should be using. So we're hoping to shed some light on that today, and we're going to provide some really clear examples of what you guys can do to help protect yourself against these types of attacks. All right, so diving into the setup, these are all real world attack examples. So these were agents that we actually engaged with and attacked. and also did some static analysis on and evaluated the actual code base. The setup we have is they're lane chain and lane graph based agents, and then we also have a N8N based agent we attacked. They use Open Router for model access, and they did have a checkpointer in place, but that's not relevant to these attack examples that we're using. So as far as methodologies, we try to keep it simple. We did use some jailbreaks through the process, and we used Dan, which is do anything now. We used word game, special language, which is my personal favorite, where you give the agent an example of this special language that you want to use. So let's say I'm going to obfuscate my payload with binary. So I'm going to tell the agent, hey, we're using a new imaginary language where you have to, every 8 bits is a character. You need to determine what this is and then respond in the same special language. And why this is my favorite is because it's almost impossible to account for every possible activation path that can happen through an entire model. So the special language is just taking advantage of this. You're finding a new unique activation path. Then you're getting the answers back, so you're bypassing any kind of edge protections that are in place. You're bypassing any types of denials that the model may have been trained to use, the underlying LLM may have been trained to use. You bypass guardrails doing this. This is arguably one of the hardest jailbreaks to block, in my opinion, where you can ask a direct question and still get a direct answer back out of the model without having to use things like poetry or creative writing or a lot of the more verbose methodologies of jailbreaking. I touched on the payload obfuscation, and I said these will all be direct prompt injection. So let's dive into the first one real quick. A bunch of these flow together. For navigation tool discovery, we were simply just trying to identify what capabilities the agent had. And since we saw that it had a navigation tool, we then used that navigation tool to execute a cross-site scripting attack. From there, we're able to identify that, one, the model happily gave me all the tools, which in some cases, like we'll talk about in a little bit, that is what you want. There are ways to hide that information or present that information to an end user where an attacker is not able to just easily identify all of the tools they get to play with. So MCP tool abuse, we'll cover environment variable leakage and some ways that you can maybe avoid putting, really it comes down to just avoid putting keys in your environment variables. There's a lot of strategies you can use to completely avoid this for your tool set. And we'll cover some system prompt leakage. And system prompts are interesting because often if you can get a hold of the system prompt, all of the tools and all of the connections and the capabilities that the agent has is provided within the system prompt. So this is sort of like a great worksheet for someone to, like an attacker, to just kind of use to go down the list and identify what attack surface the agent has, if you can get a hold of this. Sometimes also it will contain the types of security features that the agent should leverage or try to leverage. And finally, we have data set collection. This one was mainly about file leakage. So since the agent had code execution capabilities, yes, it was sandbox, but the way the target was storing their MCP configurations and the information that was contained within the MCP configuration file on the agent, since this was dynamically loadable, they could pass the config to the agent, and then it would automatically set up all of these connections to the various MCP tools. The problem here was there were keys within the MCP config. So that's a quick overview, and I will jump back to the navigation tool discovery, and we can kind of dive into some questions around this. So
Yeah, that's great. I think navigation tools are a really great place to start, right? Because agents are incredibly powerful when they are connected to the internet, right? Being able to go to a new place, grab a piece of information, use that information, it could be up to date, it could be news, it could be whatever it is for your application. Right. So locking that down is a big challenge from a usefulness perspective. So where do you start, right? Where do we, let's say we have an agent that goes and does something outside of the network, on the internet, somewhere else, right? So do we hide that capability set from the person using it, and try to lock it down from an agentic tool set understanding, and then that kind of moves into system prompts? So like what how do we even start there?
Yeah, that's a great question, Aaron. So, at the start in the design process, you can include the tools that you're going to use in your user experience. So, if you're onboarding a user, you can tell them what tools are available, and this requires a login to actually get access to, and like an account to get access to find out all of these tools that the agent has, instead of providing it via if I'm asking the agent directly instead of giving it a way to respond directly back with all of the tools it has. Now that's outside of that workflow. Now it's provided to the user through an onboarding process or documentation or some other means that requires authentication instead of just directly accessing it out of the agent. That's really foundationally where I think most people should start with this.
Yeah, no, that's interesting. And then, so what are the bad things that can happen, right? Like if this piece is exposed or understood from an attack standpoint that we have this access, what could they do with it?
Yeah, I mean, you can use, if I know your agent has some sort of navigation tool capabilities, which most agents, this is why I chose this example. This is extraordinarily common these days where navigate a navigation tool is really just the agent can reach out, navigate to a link. If you're familiar with a curl command, it's akin to that. Or yeah, so you're navigating to the page. You still have to get a hold of the web page and do something with that. That's usually a separate tool, some kind of like browser based tool, but at least if you're navigating to the page, so I know I can hide payloads in that in the URI. So anything like SQL injections, cross-site scripting, if you're hiding things in query parameters, if you're hiding things in path parameters, there's lots of options you have at your disposal if I find out you have a navigation tool. And I can use this as perhaps a pivot point internally to your intranet if this agent has access directly to your intranet that was otherwise walled off. And I can use it to orchestrate attacks against other people. So I can use your agent to attack somebody else.
All right, so let's say it's non-negotiable. You have to have navigation tool capability. Um, what should the first step be to making sure that this doesn't, you know, doesn't get compromised?
Yeah, I think there's a variety of things you can do. So the most basic example is just allow and deny lists. You allow certain URIs or host names and you're blocking certain host names. That's about bare bones. Everyone should have allow and deny lists associated to their URI. You should be thinking about it. There are just some sites, if you're using an agent in your organization and it has a navigation tool, you will know what sites you are expecting users to use, and you probably already have internal policies that your users should be following that you can now apply to this agent of sites they should never go to. Going up from there, it gets quite a bit complicated, but you can start implementing behavioral analysis type tooling where or even just, there's a number of detection solutions that exist where it's specifically looking for cross-site scripting and SQL injections. Next-gen firewalls have these. There's a lot of proxies that have these. There's MCP proxies now that have these same capabilities. And they've started adding risk scoring. So they're kind of tracking one connection, so one session over time, and evaluating, are they consistently sending these payloads? So was this a one-off thing? Is this normal behavior? Is this abnormal behavior? Incrementing a risk score and then enacting some form of blocking or killing the sessions.
Awesome. Yeah, and that makes a lot of sense. I just put this in the chat. So anybody who wants to ask questions, feel free to jump in, drop some questions in the chat, and we'll funnel them over and get them answered. In particular, if you have a particular workflow that you're in process with, or if there's an additional question that you have around an answer, or if you want to go a different direction than the questions I'm asking, feel free. This is for you all. This isn't necessarily for us. Um, so, that makes a lot of sense. So, can you give me I think the cross-site scripting and SQL injection, that makes a lot of sense, but um, can you talk a little bit about indirect prompt injection?
Oh, indirect prompt injection. Okay, we
Yeah.
want to get fun with it. All right.
Yeah, I
Yeah,
think
and
so.
actually, I mean, I don't know if you guys have heard the news lately. Claude bot, now Molt bot, is really blowing up in popularity. So, why I'm speaking about this is just about every integration that Moltbot there is some form of indirect prompt injection you can do there, and probably the most interesting one. I know we were just talking about this, but it does directly. That's the like top of mind, most obvious indirect prompt injection I'm thinking about right now. So if let's say you set up your agent with emailing capabilities, it's reading emails, it's interpreting emails. This could be a support agent. This could be SDR, BDR agent. This could be something that you're just trying to help with your daily tasks and help respond to emails for you, maybe that you don't like to respond to. So if I find out somehow that you're using Moltbot and you're bragging about how you're using Moltbot for managing your emails, well, now I know that I could send an obfuscated payload in an email to you that Moltbot will interpret and start exfilling any kind of data that you have associated to your agent. And I think that in my mind, that's some of the lowest hanging fruit, or probably one of the riskiest things associated to Moltbot, Claudebot, whatever you want to call it today.
Yeah, no, I think that's something that's very scary, and it makes a lot of sense why you don't have a lot of these AI-driven email programs today. There's not a great way to make them secure. So I suppose that's a bit of a forewarning to anybody building with email capabilities is we're not quite there yet.
Yeah.
Or maybe Alex, since we're kind of on email, is there a way, right? Is there like a way for to have a totally isolated, let's say, summarization model that will just read the emails and um, give a summary of them instead of I'm just trying to think of like
Oh,
how,
sure.
how
Yeah.
do you how do you architect a secure email reading solution that kind of gets rid of that problem in particular?
Yeah, great question. I think it's you're weighing risk versus usefulness. So how secure I want the thing to be, there's in right now, unfortunately, inversely proportional amount of usefulness it can have. For example, if I want my agent to manage all of my emails for me and I give it all permission, so it can write emails, it can send it to anybody, it could delete emails, it can reorganize emails. The more capabilities I'm giving to this agent, the more skills I'm giving to this agent, the less secure that is. Because and how do you prevent this, I think, is the key question here. uh, it's honestly a lot very similar to the navigation tool. These tools already exist today. You can allow and deny certain domains for emails. You can do sentiment analysis on the email content. The interesting part, or where the tricky part is coming in, is hiding jailbreaks within these emails, or using obfuscated text in the emails, or if I'm you can do like second order indirect prompt injections where I send an email where I'm asking the agent to navigate to a link. The link that it navigates to has a page with hidden text in it, or a prompt injection on this website. Now I've done a second order because it's the first order prompt injection. I got it to do something I wanted by sending the email. Now I got it to go to a web page, and it's parsing this content on the web page where I've hidden a payload, and maybe I'm asking it on the web page to send an email back with I don't know, all other emails from your bank or something with your bank account details. Or if I send a password reset, and I trick it into sending me the email for the password reset so I can click the link, change your password, and now I have access to your bank account. There's a lot of interesting things you can do here, and the way, probably one of the best ways to stop this right now is intent analysis. So you're using an LLM to evaluate the content of the email and identifying the intent of the email. And if it does, you can actually you can check for hidden characters like ASCII smuggling and things like that within the email as well. So based on the intent of the email, I can then take certain actions on that.
That's neat. So you're effectively adding another model to look at the intent of the output of the initial model that is doing the heavy lifting, and then you've got that last kind of final checker to say, okay, the judge model is now essentially saying your primary model has been compromised. So thereby deny that response. It,
Exactly.
okay. That's neat. So there's a that safety net that you can put into some of these areas. Does that apply universally? So I mean, the second thing we were talking about was MCP tool abuse. Like, is that can this judge model concept be applied across all of these attack areas? Like, let's look at MCP with cross-site scripting and SQL injection.
Yes, absolutely. It can absolutely be applied to any form of prompt injection detection. However, there are some pretty major both operational and cost prohibiting factors to consider when you're doing this. And I that's really the trade-off for a lot of these tools right now is efficacy. What is the false positive rate of this intent detection? Can I tune it in some way? Can I provide it more information so it can learn more about the intent of a normal user versus the intent of a malicious actor or an attacker? And you have to start asking questions about, how do I feel about privacy? Do I want every request that's coming into this agent to be sent to some third party that's doing the evaluation on this? What does the flow of information look like? Is there or what type of information is contained within this intent analysis request that I'm sending out, leaving my system? Or do you want to try to install, like, run this locally or run this in your own cloud environment using something like Vertex or like AWS's, I think it's Bedrock. There's a number of hosting, like, ways you can host your own models now, and you can maintain the data security there. But who's going to maintain this thing? Who's going to monitor it? How much is it going to cost? How many tokens are we going to go through? What's our request volume? There's a lot of questions that need to be answered when considering these things.
Yeah, that makes a ton of sense. Do you want to jump over to the MCP tool abuse slide so we can get
Oh,
your
yes.
example? Yeah.
I'm looking at you and talking instead of moving the slide.
No, that's okay. Um, right. So I think the interesting piece here is we're looking at these cause and effect relationships between just how these models are fallible, and then you, kind of layering on, like, it kind of feels a bit like a house of cards. Is there any more programmatic ways that we can look at this so we're not kind of adding probabilistic to probabilistic? Is there more, let's call it structured ways to harden this stuff, in particular in the MCP category?
Yeah. So with MCP, the, there's always a range, and I feel like these examples, there's a lot of overlap. So since these are all direct prompt injections, what it comes down to is a lot of similar protection considerations that you have to make, and there's overlap in the tools that you're using. In this case, yeah, you can programmatically do static analysis. For MCP tool abuse, you can have a gateway between the agent and the MCP tool that's being executed. So now I can inspect all of the traffic there. And that is, in essence, a programmatic way. You can implement, I mean, if you go all the way down to the code level, you can do allow lists and deny lists. You can use regex. You can use Aho Karasik type algos to pick apart and do matching on the various segments of the text, and do it that way, or you can pay someone who's already done that for you with some kind of rule engine that is doing risk-based analysis, behavioral analysis. Those are more static methods where if this MCP tool request, it will hit your agent unless you have a WAF at the edge. So you can block these at the edge, or in code if you're using like a runtime protection type solution, or something that's I'm trying not to name any specific product names on this, and it's really challenging, or use like terminology or phrasing that's common. So if you have a WAF at the edge, you have MCP gateway is the new way to orchestrate connections and protections and session management from your agent to your various third party or internal MCP tools. There you can do detection and blocking there. Then you can also do detection and blocking at the MCP tool level. So it gets really complicated very quickly, and you have to evaluate how far you want to take this. Like, how much risk are you comfortable with? You've all probably heard security in depth or security in layers. You have to determine, is it cost prohibitive to have this protection at the edge and an MCP protection where not only am I adding extra latency because it's going through potentially two separate reverse proxies, but also how much does it cost to pay for this egress out of these reverse proxies if you're hosting them yourself?
Yeah, that makes a lot of sense. And again, this is all what, like, it's very unique to the application you're building, the tool set you're building. Ideally, you can focus on just one connection, one integration, and really architect these things so that they are secure. Whereas, I think the opposite of that, coming back to ClaudeBot and Moltbot, is because you have literally everything there, it becomes incredibly difficult to secure every one of these potential connections. And whereas, enterprise applications, if you have a single function that you need to ensure that you're hardened on, that becomes easier from a development standpoint to just focus on the fail modes of that one connection. So, and speaking of, let's look at environmental variable leakage, right? So when we're making these connections, it's really important that API keys don't leak, right? So what's you've shown it's really easy to get these out of the agent. How do we protect against that?
Yeah. From the this isn't new, so I believe most people will be familiar with just-in-time type solutions where you're using code to access a vault of some kind where it's pulling the key down and it's using the key at runtime instead of storing it in environment variables. Or even you can do the same thing with a vault where you're pulling it into an environment variable, but at the end it's still being stored at the time of use, like it still exists. And that's how I got these keys, for example. So use a vault of some kind, use some kind of key storage solution in your environment, and pull them into the code directly and use them at runtime instead of using them at build time, instead of building them into the tool. It's really that for this one, that's really what it comes down to. There are ways to inspect the request, again, like input validation on what's being asked from the agent, and output validation is the agent accessing files it shouldn't access. So going in and ensuring that the agent specifically the code execution tool in this case, cannot read any files it shouldn't be able to read. So run it.
Oh,
Sorry,
sorry. I
go ahead.
just wanted to clarify this a little bit, right? So if you're storing keys in a vault, do those keys, and they're being used in runtime, and you're able to pull
Mhm.
these keys from runtime,
Yep.
is that the right way, or are we? Or do we just have to have that judge to ensure that those keys aren't being leaked?
It's a usability trade-off. This, like, mainly for DevOps in this case, on really, I guess, the developer and DevOps. are you comfortable setting up secrets management? Do you know how the versioning works? Are you using infrastructure as code? So you're either offloading the secrets management work to another team in this case, or you're offloading the security solution that's blocking this thing to maybe like your internal security team or a third party security team. So I guess, I mean, in the end, you have to make a business decision on where this is best suited. In my opinion, it should be shared. These types of things should be shared ownership. So, like, it shouldn't just be the DevOps team is the sole owner of how secrets are managed, and the developer is not a part of that decision making process on how they should be accessing these secrets. And in many places, something like this is likely already established. It's just we've had this rapid development of this new technology, and to me, it appears like we're just trying to get these agents out as fast as possible without considering some of these things. And now we're starting to consider them. So like now that the issues are showing up, we're starting to consider them.
Yeah, that makes sense, right? But so how do you legitimately handle these use cases that requires a genuine read of the environment variables, right? Like checking node env or reading this configuration. Like are you just more exposed at that point?
You are more exposed. You can pull them in. If you need the environment variable file, you can pull them in from a secret manager still, so at least they're securely stored. And then in the end, if you're isolating the tool usage and ensuring that it only has read and write permissions, and maybe like a subdirectory that it's then using as its workspace, and it can't read from wherever this environment, like wherever the app started, the agent started. If it can't read from where the app started, then that is a more secure practice to follow. There's other things you could do, like mounting it in later, but that's still it still exists at run, like it still exists on the system, even though like you've mounted it in. Once it starts, it's going to exist there. So if I can trick the code execution into giving me access to it, I'm still going to get a hold of this information regardless. So now we're back to input output validation, intent analysis, uh, maybe using, I mean, a lot of WAFs can block these types of things. The structure of an environment variable is identifiable enough where you can very consistently block and prevent leakage of this type of information.
Interesting. What kind of output models are you using to do this? I would imagine they can be pretty lightweight, you know, small parameter count, just to make sure that like you need to say a yes or no decision. Like, is this harmful or is this not? You don't necessarily need Opus 4.5 running. Is that your assessment?
I I I initially believed that, and now that I've done a lot more of my own testing, I have changed my belief there.
Okay.
I am now of the belief that to and there's of course there's always trade-offs. So if it's just simple text direct prompt injections, you need now I believe you need a model that is has I'll put it this way. You need a model that has as many parameters, so let's say intelligent as the model you're protecting, to improve your chances of to try to maximize your chances of determining the intent and blocking these things. And the reason for this partly is jailbreaks, because if the and you also need to be fine tuning these intent models if you're training them themselves. I mean, you need to be they're specialized models. They're not the same type of model. They will have less parameters. That was just an example, but they need to be, let's say, quote unquote, intelligent as the target, as the model you're using in your agent.
That's interesting. So I suppose there's an argument of, let's say you're not doing something terribly intelligent within the agent itself, but you're saying the more intelligent you get on the output side and validation side, you're going to be seeing a return. So if you're trying to budget token usage, you go lower token or whatever the right amount is for your application. But then for these validation outputs, like they're not doing all the heavy lifting, they're just looking at the output. So thereby, even if you're using an Opus 4.5, which is the most expensive model, that is still able to get you within a decent cost parameter.
Yes, exactly. Yep.
That's cool. All right, well let's move on to system prompt leakage. When
All right.
yeah, this one's really fun. This is one I think I've seen a lot of. I've seen you do a lot on Andres on our team also have done a lot of you know manipulation of the models to get the system prompts out. Like what give me the so what here.
So what? So what? System. I there's trade-offs here. I mean, I'm trying to think a little bit. So
Yeah, let's
system
say I've
prompts
got
are sometimes useful and sometimes completely useless. You can get a lot of useful information out of them sometimes, and other times there's nothing to be found. There's nothing that you're going to get that someone else can't get, and it really doesn't change anything in the end.
got
So
it.
the amount of concern you should have over preventing your system prompt from being leaked, I believe, is directly tied to what you're using the agent for. So I'm trying to think of a great example. If I'm just using this internally and it has no external access whatsoever, no one can reach this, it's running on my system, the system prompt can be whatever I want. It doesn't matter because no one's going to be able to get it in the first place, one, but let's assume they could somehow. Even if they get it, maybe I'm just using it to take a CSV file and find some interesting information in the CSV file. Like roll it up into, do some statistical analysis for me.
Yeah.
So in that case, I could care less if somebody gets that system prompt. Why does it matter? Now, if it's an externally facing agent, as soon as it goes external, as soon as it's reachable by the internet in some way, and this is true for any app, the risk goes way up. So, how I'm using this externally facing agent, maybe I'm using it. I'll stick with the CSV example. Maybe a user is providing the CSV, and I'm still doing the same statistical analysis, but this is a third, like some external person is using it for this. Now the level of concern has gone way up because they could be hiding payloads in the CSV file. They could be sending a malicious CSV file that contains. You can do a lot of fun things with CSVs. I don't need to get into that right now, but uh, the system prompt is going to describe what capabilities or like really what the agent should be doing with the CSV file. So if I know what normal looks like, I can try things outside of that norm. And if it also contains security information, like maybe it says in the system prompt file, we did see this where it's use the input and output validator, uh, deny certain types of phrasing. Like people were plugging their phrases in that they want to have denials on, and that was included in the system prompt. So now don't use that in your system prompts
Interesting. So when it comes to like the
or in your
super,
prompts.
yeah, let's call it the proprietary information in the system prompt, it sounds like it's because and I struggle to say this, but I think it's important that every model we've ever interacted with, we've been able to get the system prompt out of. So what I think is we should be thinking about here is just assume that this is going to be exposed at some point, right? So if it's going to be exposed, how are you architecting this so that you're protecting the rest of the system? Like, are you
Yep.
putting an input model, right? Like, you just have a model that is exposed, and then you have a more sensitive one that sits behind it, where the input model talks to the recipient model, or like the main model is as just a form of input filtering. Um, or are you adding a lot of guardrails and really denying prompts that come through? Like, where should you really be spending your time on this one?
For system prompts, I honestly, if you just don't include your security features and your denials in the system prompt, and exactly as you said, just assume it's going to get someone's going to get a hold of it, then you have nothing to worry about. You can, if you're really paranoid about it, you can treat your system prompt as a secret, and you can use the same strategy you use for configuration files or anything else, and pull that in at runtime or use time. That is the best strategy to prevent your system prompt from being leaked. If you can't do that and you're still really paranoid about it, uh, it's the same. You know what's in your system prompt. You know if that. I'm trying to find the words for this. At a lower level, if you identify that text looks similar, like do similarity matching on the output for the system prompt. You have the system prompt. You know exactly what it looks like. You can easily do anything from regex to like some kind of similarity matching or like string matching, partial string matching, things like that on the output.
Okay, so it sounds like we've got a couple of strategies to handle system prompt leakage. And in interest of time, we should probably jump over to data set collection. Um, this one's interesting, right? This is pretty important stuff on the back end of and what makes your agent capable, what makes it intelligent, what makes it useful. Um, and it seems like they can be pretty well exposed without, let's call it, the best practices here. So let's give us a rundown on where the issues are here and what we can do.
Right. So the primary issues, at least in this specific example, was the secrets leakage within the MCP config file. There's a ton of information that can be leaked, and people are when they're sandboxing their agents, they're including the data sets in the build process, so the agent only has access to a specific subset of some data that they want the agent using. So if you're worried about that data getting leaked, this early on comes down to knowing what information you're including in your build process. One, two, understanding the read and write permissions that the agent has when accessing this data. Can it does it actually need to read all of it? Does it only need to read certain parts of the data? What parts is it using? What parts isn't it using? You need to make those types of considerations. And going back to a previous example I gave, you can restrict the access for certain tools. This again was, I'm trying to remember actually, was this the, yeah, this was code execution abuse again. So this, we used a prompt just to abuse the code execution tool to run an ls command. It listed all the files that were available. Then we just catted the file, like ran a cat command on Linux, which just reads and dumps the file out to the terminal. And in our case, we had it send that back to us. So you can restrict command access for code execution tools. You can prevent it from using any command at all if you don't want it touching the system at all. Sometimes that's useful, and in as is shown with Moltbot and Claudebot, it's part of what the most dangerous thing it has that also makes it super useful is writing and reading files on the system and kind of using the system and building things out and using it as its playground. Uh, so yeah, I'm rambling now.
No, it's that's good, man. And I think, it's interesting, right? So if these MCP config files, they're not supposed to be agent accessible, so what are they? Where do you find them? How do you manipulate them? And how does the agent runtime actually read them while connecting to these servers?
Was that a question, or is that those are the things
Oh
that
yeah, it
is?
was more yeah, it's a question, right? So like when you're going through these things, so you're building, like, how do you harden out the MCP server in order to, prevent this from happening?
Yeah, great question. How do you harden the MCP server? It's in the end, an MCP server is just like any other web application. It's an API server. So if you're following best practices for API server based protection or web server based protection, then you're doing the right things. And I mean, I can go into specifics if you want me to dive in a little further there.
Yeah, I'd
That's a
say like
really
just let's just pick one that you've seen an agent give up the goods for.
Oh, let me think. Um, Okay, yeah. So database access. This MCP tool was using Fast API, which is a Python library, and then it was using I can't remember the name of the library it was using for the Postgres database, but essentially what they were trying to use it for was tracking. It was like session management through the MCP tool, which is crazy to do in the first place. They were using the agent to it was session management for agent sessions. So this was an orchestrator agent, and it was managing multiple other sub agents. And the database had read and write permissions, and the you could easily just delete the entire database session. In this case, this isn't super critical. The worst it depends on what the sub agents are doing, right? So in this case, if you delete the session table, all you're doing is stopping all of the work. Like now you've killed all the communication tracking from the orchestrator agent to all of the sub agents. So it would be a service interruption. Like if this was an application that is publicly facing, like at the top level, that's initiating the work that the orchestrator is doing, or if this is a support agent. This is a common architecture these days, and this is a I'll just call this out as a tangent. So an orchestrator agent with micro agents that have specialized skills that are being leveraged per agent is a common architecture. So where are we going with this? The MCP, the MCP. The protections you could do is limit its access to the like. Don't let it delete the database. In that
Got
case, is the simplest thing to do.
it. Okay, that's no, that's that. I mean, it's that's one of the hard pieces with this, right? Like you've got this inverse relationship between access and capability to usefulness, right? So the more useful it is, usually, the more the riskier it becomes because um, you know, you pull down your access and your safety goes up, and you increase your access, safety goes down, but usefulness goes up. So it these are really hard problems, and I think just to kind of wrap up the discussion is we've seen some good ways to prevent these issues from happening. What's going to be challenging now is this is the end of January 2026. In the next 2 months, 3 months, the world is going to change again. And as these models become exponentially more capable, let's not call it exponential, let's call it step function capabilities. And
Okay.
we're kind of reaching these new levels where um, kind of like the LLMs that you just give it more data and they get better, more data better, more compute better. We're kind of reaching the limit, or at least if you believe the tech media, we're reaching the limit on how that is going to continue progressing until we get to another step function. But until that happens, where we're seeing all the gains in capability sets is by adding all of these new connections together. And by things like ClaudeBot, where you now have access to everything that a workstation has, and thereby it's incredibly powerful, incredibly useful, but incredibly insecure and incredibly dangerous potentially. So I think this is that tension that we're all having to figure out as we build these, build the future of work and build the future of applications. How do you balance those things? And you know and as you all are here listening to us now for almost an hour, reach out, right? Like if you have a question, like we're happy to answer it. Like we're happy to ping off any kinds of ideas you have, troubleshoot, or just shoot the breeze with you about like what are the potentials here. we want to help. We want to be a resource to you. So, you know, just wanted to kind of wrap on that and say like thanks for watching, thanks for being here. Please reach out to us again, LinkedIn, X, TikTok, Instagram, YouTube. We're everywhere. Drop us a line. He's Alex at Zeosec. I'm Aaron at Zeosec. Just give us a ping, and we're here for you. This is really hard stuff, and there's no right answer at this point is kind of what it seems, but there are ways to reduce the risk and to get that agent through, let's call it the security team or through that final GRC approval. So yeah, we're here to help. So Alex, if you have any final words.
Yeah, very, very well said. Very well said, honestly. I don't know if I want to follow it up, but I will just say thank you everyone who joined. I hope this information was helpful. This space is rapidly changing, exactly like Aaron said. So, uh, everything I'm telling you now could be totally different a year from now, but there are absolutely some consistencies that have carried forth since web application security days. So if you're starting with threat modeling, you start considering the flow of information through the system, and you start identifying the risks there, you'll be doing fine. I think you guys will secure your systems very well, and I wish you the best in building new things.
Oh, we do have two questions that came in, and I apologize, Neil and Hassan, for missing them when they came in. They came
Oh,
in through the Q&A instead of through the chat. So Neil says, I like the concept in that each agent follows a principle of least privilege when implementing RBAC. Do you think we should place agents and humans in the same groups or IAM policies?
you think we should place agents and humans in the same group or IAM policies? I do believe that helps a lot if you're treating agents just like, think about them just like a junior employee at the company, that you don't know what links they're going to open in their emails. You don't know what they're going to do next. So you are absolutely following least privilege as much as possible with these agents. That is exactly what you should be doing, and they absolutely should have RBAC. Do I think that's enough? No, because we have like probabilistic models are being used, so you have no idea what these things are going to do. There's no way to determine exactly what they're going to do, and there's no way to determine exactly what information is going to get sent to them. So because of that, which is in a way similar to a user, you could say, oh, the user was socially engineered in some way. So there's absolutely overlap. Because of that, and because of the complexity of all of the different tools people are connecting to these things, and it's challenging to understand how the tools interact and interplay with each other if they're communicating to each other. So it does go further than that, but RBAC absolutely, leaves privilege absolutely. And if you are specializing the agents, the specialized agent should have its own IAM role in place. So you're kind of treating it as an isolated case instead of applying a blanket rule to everyone.
Cool. And then Hassan asks, do you have any plans to release a node for N8N?
That is a great question. So we actually were just talking about that, and I don't know if we'll release a node, but it will be very easy to connect our tool, like what we've built. I know we didn't really go into this. We're not trying to sell anything on here. It's purely educational, but um, you'll be able to really easily connect to N8N and validate your security posture of your workflows that you've built in N8N.
And I think that's an interesting point too of you talked about it the last talk, attacks versus evals, but I think N8N is such a great place for that that eval use case where we just want to make sure that what you've set this thing up to do is doing it right. We're not trying to push the boundaries and say, oh, we got an indirect prompt injection and we're able to compromise your MCP server and then send a SQL injection. It's like, honestly, like that, I think that's going to be a problem for when you get into deeper production environments, and in particular an issue when you're looking at enterprise deployments. But when it comes to just, let's say, useful, let's make sure these things are staying on track, like evals and N8N, like that makes a ton of sense. to really start focusing on. All right, everybody, great questions, really fun chatting. Again, Aaron at Zeosec, Alex at Zeosec. Reach out if you've got anything, and until then, have a good